Ladies and gentlemen, what pretty flowers, welcome to almost spring. I have no idea, it's getting closer. Anyways, here we go. Here's your central question. Section 4 of Chapter 10. This is going to be the first video lesson I'm going to do with this section, and it's going to be a bunch of definitions and what we're going to talk about in this video real quick, and get ready to write. But it's going to be how do you identify things called secant lines and secant segments. And then we're going to go to tangent lines, tangent segments, and things called tangent circles. And I'm going to pull all this together and show you how they relate and how they don't relate. And really the bigger thing that we're going to talk about is this word tangent with this section. So let's dive into it. I'm excited. Secant and tangent. Okay, so in your notes I draw this circle right there. So we're talking circle A. And this point up here is B. What is the difference between a secant line and a tangent line? Well, here's your definition of secant line. It is a line that intersects a circle at exactly 2 points. Now, I don't know if this helps you or not, but here's how I kind of see this. A secant sounds like second, and second, it means 2. So I don't know if it helps or not, but that's how I remember. Secant means second. Well, it doesn't mean second. It sounds like second, which means 2. So what's an example of a secant line? It looks like this. It is a line that keeps on going forever and ever and ever and ever in 2 different directions. It's a line, just like that. But it intersects the circle at 1 spot and a second spot. That is a secant line. Wonderful. That's pretty simple. So, I mean, you could draw all kinds. Right there's one. There's a line. That's lovely. You could draw one that goes right through the center, whatever. That's not the diameter because it's a line that keeps on going. But that is a secant. You could draw one like this. Woo, whatever. As long as it keeps on going forever in 2 different directions and it intersects 2 places, that's called secant. Let's go over here to tangent. What's the difference? Well, secant means 2. Tangent is where it intersects at only 1 point. Now here's the trick with this one. Sometimes people say, well, wait a minute, is this a secant? What a great question. It intersects at only 1 spot, but the problem is, let's go back to this key word, guys, line. Is that a line? It certainly isn't. If this was a line, it means it would extend on forever in that direction, and it would extend on forever in that direction right there, which means, now we're talking about a secant because it intersects 2 places. So what's a tangent line look like? Well, here's exactly what it's going to look like. I'm actually going to use this program. I'm going to put it up right here at point B. And here's what a tangent line looks like. Right there like that. So it keeps on going. You can see it goes the whole way off your screen over here to the right. The whole way off your screen over here to the left. That is a tangent line and intersects the circle at exactly 1 point. And that point happens to be right there. So a tangent line will never go inside the circle. It just goes so close that it just barely touches the actual circle. Here's another one. If I could draw another one. Whoops, sorry. Let me erase this. Let me draw another one. Bam. There you go. Just like that. You can see it actually changed colors whenever I got a chance to put it on there. So let me move this over here. That's not a tangent yet. Hold on. That's a secant. Now we're talking, bam, tangent. Just intersects exactly 1 spot. Now, here's what you have to write into your notes because there's something very important about this point right here. The point at which the tangent intersects the circle, has a special name. It's actually called this. I think I could type it in here. Yep, it's called the point of contact. Or you also might see it called the point of tangency. There's your 2 words that you're going to see that thing right there called the point of contact and the point of tangency. So that's again this point right there where the tangent intersects the circle, point at which the tangent intersects the circle. Now that's important because that leads to this next postulate, which is extremely crucial. So this postulate, you need to write down again this picture, I guess if you will, with this tangent line. Right there is your point of contact. Here's what the tangent postulate says. And there's a converse to it as well, but this is the one, if you learn this one, of course the converse is just the converse. A tangent line is blankety blank blank blank. Let me just put it up here for you so you can actually write it in your notes. A tangent line is perpendicular to the radius drawn to the point of contact. What that means is this. If I have my tangent line right here, B is my point of contact, A is the center of the circle. If I draw a radius to the center of that circle like this, a radius from the center to the point of contact, what this postulate says every single time is that it's going to be perpendicular, and you can see right there the measure of the angle is 90 degrees. It is always that way. I can move this anywhere I want to. Check this out. As long as the actual line BC stays tangent to the circle where it intersects only at one spot, that is always going to be tangent. I don't care how big. Whoa! I don't care how big the circle is, or oh, how cute little circle. Oh, it's so cute. Oh, hello, little circle. I don't care how big it is. Doesn't matter. As long as we have a tangent to the circle, bam. It's always, you can see there, it was always 90 degrees. That is a huge postulate that you're going to use a ton of times. So, we've talked about tangent and secant lines. Let's now move over to tangent and secant segments and see what the difference is. So a couple more definitions that go along with secant and tangent is a secant segment versus what a tangent segment is. Now you got it. If we go back to tangent lines, these guys right here, they were lines that intersects at two points. Secant was 2 points. Tangent was a line that intersected at 1 point. We're talking about lines. If I cut to this, secant segments, you got it. It's the same idea, it just happens to be a segment. Yes, a tangent segment is the same idea. It intersects 1 point, but it happens to be a segment. Again, though, here's the key thing about a tangent segment, guys. It is not new. It is not the one that I drew before where it looks like this. That's not a tangent segment. Even though I gotcha, it is still intersecting in one spot. A tangent can never go inside the circle. Ever. So how does a tangent look then? Well, a tangent would have to look like this, where I just kind of draw that thing out there. Now that is a tangent segment. Why is it a segment? Because it doesn't go on forever in both directions. So that thing right there is an example of what a tangent segment is. It has two definite endpoints, an endpoint there and an endpoint there. And one of those endpoints of the tangent segment happens to be called the point of contact. Sweet. So what's a secant segment? Well, here's the tricky part about a secant segment. A secant segment is not this. It's not one where it's a segment that starts out here and goes the whole way through and stops right there. That's not what a secant segment is, believe it or not. You have to look in the book for the exact definition if you want to write it down, or just kind of replay what I'm going to tell you. But here's what a secant segment really is. Let me erase this. Okay, ready? A secant segment, yes, it's a segment that intersects the circle at exactly 2 points, but here's what it is. If I drew this thing through there, where that thing, as you just saw, is the whole entire secant line. A secant segment is this. It is just part of the secant line where it takes a point outside of the circle on the secant line, and it is extending, if you will, or encompassing the points from that point the whole way here, all the points, to its furthermost intersection point of the circle. Because here's the first intersection point. The furthermost intersection point's over here. So that's a lot of words, and that's what it says in your book. But it is just this piece right there, that whole thing, where it starts on the circle, goes through the one intersection point, and out to some other point in the external side of the circle. That whole thing right there is called your secant segment. Okay? Up here is your tangent segment, so a point of contact, and then to a point somewhere out here on the tangent line. Really, it's just part of the tangent line. Now, let me give you a couple other definitions with it. So as this whole thing is called the secant segment now, that's the secant segment. This piece out here, because there are two pieces to it, this piece right here, I'll highlight it in blue. That highlighted piece right there has a special name. And I'm going to type it up here for you. Whoops. I'll just write it. It's called the external part of the secant segment. Bam. Sorry, that's a little bit ugly, but you get the idea. So that piece right there, from the outer point to the first intersection point, that's called the external part. Now, what would this piece be called? The other part, from this point of intersection to that guy right there. Now, you know that one. What's that one called? You got it. That's the chord. So the whole secant segment is that thing. The thing inside is the chord. The external part's that. So those are all words that you're going to need to know, and you're going to see those as we go through a couple examples here with this section. Okay? Let's rock and roll. Let's move over to the first theorem, if you will, in this. Well, actually, I think it's the only theorem in this section. And it's called the two-tangent theorem. And here's what a picture would look like, something like this. And now here's the scoop. If we have this point E, that's outside the circle, and DE is a tangent segment, and EF is a tangent segment, F is a point of contact, D is the point of contact. I wonder if there be any speculation on your part about the length from D to E and the length from F to E. I wonder what we could do. Well, if I ask you to prove this in a two-column proof, I bet you could do it, and here's how you do it. You would take this and say, well, let's draw this guy right there. Let's draw this guy right here, a radius to the point of contact. Oh, wait, I'm drawing a radius to the point of contact. We just learned a postulate that says that they're perpendicular. Let me draw this other radius to the point of contact. Oh, well, that's not really close. That's a little better. That radius drawn to the point of contact is perpendicular, therefore they're both right angles. So I got that to be a right angle. Wait a minute. What I just drew is a radii. Two radii. So those guys are congruent because they're radii of circles. And reflexive property gets me that thing. So that proves triangle on top congruent to the triangle on the bottom, which means through CP/CTC, you got it. Those tangents are congruent. What I just showed you guys is exactly what the two-tangent theorem says. It says, by definition, well, no, by theorem, if two tangent segments are drawn to a circle from an external point, then those segments are congruent. Happens every time. So here's the example. Look, these guys are 8.46. So DE is 8.46. FE is 8.46. If I move this point in here, I don't know, can I do it? Here, I'll move D. So they're still tangent. Notice it's still just going through. If I extended this, it would keep on going outside the circle. But notice the two tangents are still the same length. If I make it like this, really, really small, doesn't matter. They're still tangent because it goes outside the circle. They're still the same. If I make it really, really big, whoa, it's going to go out. Oh, it's off the screen. Whatever. So they're still the same length. So that is your two-tangent theorem. Very powerful theorem used in two-column proofs. And oh yeah, by the way, when you use this in two-column proofs, I am 100% cool if you just write two-tangent theorem. You're welcome. High five to you. Sweet. Okay, last thing. Let's talk about what this means for circles to be tangent. The word tangent, remember, means intersecting once, and it's no different with circles. Tangent line, tangent segment, and tangent circles. Here's a quick sketch of tangent circles. Let me use my circle thing. So let me make one circle. Woo, there's one circle. So here's an example of an externally tangent circle to another circle. Here I'll draw another circle, and notice where I'm getting closer and closer and closer, and watch it change colors. Bink. So there you go. You can see at this point right there, this point of contact, if you will, from the circle to the circle, that is an example of two circles that are tangent to each other. Externally tangent, because it intersects at one point, and they're external of each other. They don't go inside of each other. Well, what's internally tangent then, you might ask Mr. Motter? Well, let's just move this guy and go like this. Whip, like that. So now we're talking internally tangent, because if you notice, this point right here is still the only point where they intersect, and this little circle is internally inside the bigger circle, intersecting only one spot. That is internally tangent. Sweet, that's it. Simple as that. So this is externally tangent. That is internally tangent. External, internal, external, whoa, that's weird. Internal, external, external, off the screen, whoa, internal, lovely. Now watch this. I don't know what that is. Ooh, that's lovely. I have a point there, all this stuff. That's nothing. That's just intersecting circles. It has nothing to do with tangent. There's nothing called secant circles, you know, like externally secant circles. Nope. We only have tangent circles where that guy is externally tangent, or we got internally tangent. So, awesome. You guys are amazing. A lot of notes. Go back and rewind this, pause it, do whatever, but you'll get all your notes that you need. But secant means two intersections. Tangent means one. And you got the postulate, which is a very powerful postulate that you're going to use a ton. And you got the two-tangent theorem. We'll see you guys in class. Have a great night. Later.